Good evening, ladies and gentlemen. In this presentation, I will be discussing the case regarding the company Cook Composite and Polymers. Cook Composite Polymers, in short CCP, is based in North Kansas City, Missouri. They are a leading manufacturer of gel coats, unsaturated polyester resin, coating resins, and emulsions. In 1918, Charles Cook started the Cook Paint and Varnish Company. While most of the company was acquired by a larger paint company in the 1980s, several descendants of Charles Cook retained the selected Composites asset. In 1990, these family members entered into a new joint venture, Cook Composite and Polymers, with Francis Total, one of the world's largest oil and gas companies, and a major chemical manufacturer. Total owned 70% of the new entity, while the family owned the remaining 30%. Throughout its history, CCP had been innovative on a number of fronts, including product quality, waste control, automation, and designing products that emitted low levels of volatile organic compounds. It now had begun to think about how to reduce the environmental impact of its manufacturing process. CCP's engineering and loss control VP Mike Gromacki had been tasked with rethinking how to handle the styrene CCP used to rinse mixing vessels between production batches of gel coat. He wanted to explore the way to reduce the cost and waste of rinse styrene while maintaining the product quality. Gel coat was manufactured in batches. The North Kansas City plant had 15 mixing vessels, each with 550 gallons capacity. To manufacture the gel coat, it takes 30 minutes of preparation time, 90 minutes of mixing, 30 minutes of quality assessments. Due to their high standards, 50% batches require 2 rounds of mixing and quality assessments. 50% requires 3 rounds. In case one batch is rejected after 2 or 3 runs, they will be devalued and wait for collection of disposal. Or, if there is a potential market for off-spec batches, they'll be sold to cover the cost of disposal and rejected batches. It takes 30 minutes to transfer a rejected batch to the appropriate area. It takes 30 minutes to empty, rinse the mixer and vessel once quality was approved. The production of gel coat in North Kansas plant follows 3 8-hour shifts per day, 5 days a week, with 2-week annual shutdown for maintenance. A successful batch on average takes 6 hours from the preparation stage to a finished product. Then rinse and empty the vessel. With the company's 15 vessel capacity at the plant, they can make on average 60 vessels of gel coating in a 24-hour period. Any delay in a single batch process would potentially slow down the whole process. Therefore, effectively rinsing the vessel is the key to the company's operating efficiency. In 2017, CCP was the world's leading manufacturer of gel coats. CCP's clients often ordered custom gel coats with very tight specifications, so quality was crucial and mistakes could be costly and result in significant product liability. As a leading gel coat supplier for the marine industry, CCP worked with many major boat manufacturers. On average, CCP makes $10 per gallon of gel coat. Based on a batch of 550 pounds of gel coating, CCP makes 5,500 per batch on average. Gel coat made up less than 20% of CCP's revenue, but generated as much as 30% of the company's operating income. CCP is under the scrutiny of joint and several liability rule. which holds CCP responsible in any part of the wrongdoings occurred during the disposal process of their hazardous waste, mainly the ring styrene, meaning even if CCP contracts licensed third parties to handle their waste, they're still liable for any accidents happen during the disposal process. In the past, CCP explored a waste exchange method of disposing the ring styrene by giving it to a Florida-based company to use in their artificial reef structures. The Florida company, however, left the ring styrene sitting under the Florida sun instead of recycling it. EPA, the Environmental Protection Agency, notified CCP of the situation, and CCP took immediate action to safely dispose the ring styrene. However, EPA still demanded a near $500,000 reimbursement for overseeing the whole process, which as a result amounted to a near $1 million loss for CCP. Therefore, EPA persists as a substantial cost for CCP through their stringent requirement of the disposal method of ring styrene. It will be beneficial for the company to explore a less costly and safer means of disposal of their hazardous waste. In late 2004, Gromacki became aware of byproducts energy. BPS encouraged companies to recognize that one company's waste could be another company's raw material, and to think of waste as byproducts that elicit business opportunities. The Kansas City Regional Byproducts Energy Initiative was launched in July 2004 through the effort of many companies and organizations. During a meeting in June 2006, Gromacki learned that another BPS initiative member was planning to repaint its concrete storage area, and that the concrete coating would need to be resistant to water, chemicals, and forklift traffic. While most concrete coating available on the market were based on chemical formulations that did not use styrene, Gromacki wondered whether his company's ring styrene could be the foundation of a product suitable for this infrastructure application. Therefore, Gromacki ran an internal pilot test for the new polyester concrete coating that used ring styrene as the base ingredient, ultimately identifying the version that performed the best. Once CCP was convinced that its concrete coating was effective, Gromacki approached Kansas City Regional BPS member Harley-Davidson regarding its concrete coating area and potentially use a CCP styrene-based concrete coating at its plant. Harley-Davidson's management was initially uncomfortable with the idea of using such a product, but eventually concluded that the anti-corrosive properties of the ring styrene-based polyester concrete coating would be effective in its manufacturing environment. After the application in March 2007, through the third-party contractor had been completed, CCP continued to follow up to assess the coating's performance. CCP now has two major issues to tackle. The first one is the cost of disposing the ring styrene as a hazardous waste product, and the second, the environmental effect of the ring styrene, mainly the carbon dioxide emitted through the production and transportation of ring styrene. We have known that currently it costs CCP 20 cents per pound to dispose the ring styrene, which according to the management team, purchase and disposal cost of ring styrene constitutes a significant percent of the total cost per 10-drum batch. As a profit maximizer, CCP has little chance of reducing the purchase cost of ring styrene, but they have ample potentials to minimize the disposal cost of ring styrene. The second problem arises as a good deed of the company. As an innovator on a number of fronts, CCP is very environmentally conscious and is actively exploring methods to reduce the environmental impact of its manufacturing process. Therefore, the best possible outcome that solves the two major problems simultaneously will be a solution that can reduce the disposal cost of ring styrene and achieve a reduction of net emission at the same time. CCP now has three potential paths of disposing the ring styrene. They can keep contracting Phillips Service Corporation, which collects CCP's hazardous waste, combined with other waste, then shipped to the cement manufacturer to use as fuel to fire their energy-intensive cement kilns. Currently costs them 20 cents per pound to dispose the ring styrene through this method. Their second option is to keep exploring the ways to dispose the ring styrene through a waste exchange program. And lastly, CCP can proceed with the development of styrene-based concrete coating, which saves CCP the disposal cost and amounts to a total profit of 40 cents per pound. Let's dive deep into the first option. CCP's first option to keep using Phillips Service Corporation means that they will stay on the old path and no longer have to take on the risk of developing the new styrene-based concrete coating. And CCP's brand image will be preserved. Another important factor to consider is that Phillips Service sends those waste to use as fuel for cement kilns. 1 pound of styrene can fire 20 pounds of cement, and each pound of cement can save 0.06 pounds of CO2 when compared to using fossil fuel. However, there are several downsides to this option. First, the cost of disposing hazardous waste is expected to grow at 5% per year, according to the management team. Therefore, from a profit maximizer's point of view, it's not sustainable to keep using Phillips Service to dispose the hazardous waste. In addition to the rising cost, there's always the possibility of an accident happening in the future during the process of disposal, which CCP will be held liable under the EPA ruling. Well, in conclusion, although sending styrene to cement kilns will save the environment, keep using Phillips Service would be too costly for the company. Our second option is to explore the waste exchange program. CCP has previously explored this option with the Florida company, which resulted in a loss of $1 million for the company under the joint and several liability rule, due to Florida company's mishandling of the ring styrene. Despite the previous incident, waste exchange does provide many benefits. If CCP were to match with a reliable counterparty, they can not only save on the disposal cost of styrene, but also make money selling styrene waste to customers in need of it. Therefore, a well-executed waste exchange method would not only allow the company to stay in its course, but also save the cost of disposal and generate some additional income for CCP. However, a reliable waste exchange partner is difficult to come by based on CCP's past experience, and it's difficult to quantify the economic and environmental impact of the waste exchange approach, as we do not have additional information about it. CCP's last option, their most innovative and adventurous approach, is to develop their low-end styrene-based concrete coating as a marketable product. This is by far the most interesting path, and there are several benefits and drawbacks as well. CCP will face significant R&D effort to develop this new coating product that meets the company's high quality and standards, along with an estimated $3 million startup cost of development. Aside from the technical issues, CCP also need to address the internal pushback of this new product. Sales and technical staffs are discouraged as they do not see potential in this low-end product, and they do not feel comfortable about CCP deviating from its core principles. However, the low-end styrene-based concrete coating has the potential to solve the cost and environmental problem simultaneously. Producing 1 gallon of concrete coating based on ring styrene will save 7.3 pounds of CO2 emission as compared to conventional methods. In addition, the concrete coating has a profit margin of 40 cents per pound of ring styrene used. In conclusion, although CCP will face many uncertainties developing the new coating product, they will be rewarded with huge benefits in the future if successful. Upon finishing the quantitative analysis, my recommendation for CCP is to pursue with the development of styrene-based concrete coating. My recommendation is formed after considering both the economic and the environmental impact of keep using Phillips Service Corporation to handle hazardous waste, and the option to develop the new coating. While we can explore the waste exchange initiative, we cannot effectively quantify its impact. The first criteria in determining which action to take is to compare the profit in each situation. If CCP were to keep using Phillips Service to dispose the styrene waste, it will keep costing them 20 cents per pound of styrene, and CCP would use 551.78 pounds of styrene to rinse the mixing vessel to achieve the most economically efficient outcome. The profit in this situation is projected to be $755 per batch. In contrast, in the absence of EPA, CCP would have zero disposal costs, and they will have increased the ring styrene usage to 557 pounds per batch, which results in a profit of $872 per batch. To summarize, EPA's present cost CCP $117 per batch of gel coating produced. Lastly, if CCP were to pursue with the development of styrene-based concrete coating, they not only save on the cost of disposal but also generate an additional profit of 20 cents per pound of styrene used. In this case, CCP would increase the styrene usage to 585.5 pounds per batch and generate a profit of $1,106 per batch of gel coating produced. In conclusion, after the profit projection in each scenario, developing the concrete coating would be a better choice for CCP. Second criteria concerns with the environmental impact of each approach. By contracting Phillips Service and sending styrene to use as fuel for a cement kiln, 1 pound of styrene fires 20 pounds of cement and saved 0.06 pounds of CO2 per pound of cement produced. If we consider a 550-pound batch of styrene, we will save in total 660 pounds of CO2 emission. In contrast, if CCP were to proceed with the development of styrene-based concrete coating, they would save 7.3 pounds of CO2 emission per gallon of concrete coating produced. Based on a batch of 550-pound styrene used, CCP will save emission by 1,063.6 pounds of CO2. Therefore, using styrene as a base for concrete coating is clearly more environmental friendly. To address some minor issues and provide further justification for proceeding with the development of concrete coating, by developing the new low-end styrene-based concrete coating, we can cater to the low-end group of customers who were previously untapped. Since CCP have some degree of market power, it wouldn't be difficult for them to develop a market for this product. In regards to CCP's brand image as a high-end gel coating maker, if they were to provide a good quality, low-end concrete coating, there's no reason for any potential damage to the brand's reputation, as they will have held their standards and kept providing their customers with high-quality products. And CCP can potentially launch a campaign about how they have changed and expanded their corporate culture and innovation. As per the unmotivated sales team, CCP could provide them with a higher commission when they sell the concrete coating to motivate the team, and this is beneficial for both parties. Lastly, CCP will not have to worry about the persistent EPA anymore, as CCP essentially recycles the waste styrene themselves. Thank you very much. This is the end of presentation.